we meet yet again. As promised during our last time together, today we're diving into the knowledge pool in order to learn how to use our new game engine. The Forethought engine provides a lot of options to developers, each unique in their own way. Before we drop into the details, a quick shout out to Bitch Hell, a short game about rage-fueled nightmare made by JC and Evie. I'd like to do a short segment like this in each video, shine some light on cool projects that I think deserve more attention. Now, back to the topic. Previously, with Godot and Godot setup, there were very little options when it came to the formats and tools. One, the only format supported was the map text file, and two, it only intentionally supported Trench Broom, with other editors being accidentally supported if they could provide a similar file. Going from such a limited workflow to having so many options may instill a bit of a choice paralysis. However, as you'll soon notice, some options are clearly superior than others, at least in my case. Before we start with the details, I'd like to bring everyone on the same page. To put it very shallowly, maps usually come in two forms, uncompiled and compiled. Uncompiled map is the file you create and edit with your map editor. Every time you make a change, the editor saves that information as text into a file. This format is what Godot reads in order to build the map you see in the game. However, Quake engines don't quite work like that, but this is why we use compiled maps. Is the file you load in the engine and play around in. The steps and simultaneously reasons to do this are: Step 1. Building a 3D model out of brushes in the map file rather than have it be built when the game loads. This reduces load times. Step 2. Calculating the visibility throughout the map. Not every part of the map needs to be visible at all times because the player cannot see the entire map at all times, so we don't render everything at once. This is called culling. In the case of Quake engines, the space is divided or partitioned in such a way that it can be represented as a binary tree. This process is known as binary space partitioning. Step 3. Calculating the light presence within the map, also known as light baking. We can pre-calculate how the lights and shadows will appear and save our PCs from having to do that over and over again while the game is running. And at the end of this process, we receive a fully compiled Fbsp file. Some of you might have noticed that the information about enemies or the player was left out from this process. This is because the map compiler doesn't deal with that data. It merely writes down the name of the entity and any additional info like the location, rotation, and lets the game engine deal with that. Now that you know what a Fbsp file is, we can go down the list of formats we can use and what makes them unique. To explain this as simply as possible, I've decided to split them into three categories. The ed family used by id Software at some point, mainly for Quake, but they're fairly similar to each other, with each generation expanding some limit of the previous one. They all have unique quirks, as you'll see. Quake 1 DOG. For today's standards, it has some harsh limits, but they were necessary back then if you wanted to run the game on DOS. The quirk of the format is that the map file contains the texture data within itself. This makes it simple to share maps, since the mapper does not have to worry about whether the player will have the access to all the data needed to display the map correctly. However, while creating textures, we're constrained by a palette. To be more precise, this one. These are all the colors available in Quake. The last row is always displayed at its maximum brightness. It's possible to create a custom palette and use that, but I'd rather not commit to a limit like this. Limits can be fun, but I do not intend to work on this project alone, and it would be unfair to impose a constriction like this while alternatives exist. Forethought, being the neat bundle of features it is, gives us an option to override textures. This means that any texture placed outside of the map file that shares the name with the one inside the map will have priority. This renders the textures placed inside the map redundant. Having the textures within the map also means that for each map containing that texture, we're storing yet another copy of that texture. And doing that, when all of them could just load the same external image, is silly. Of course, we could just strip the textures from the map and only use the external textures, but that just adds an unnecessary step to the process, because the future formats already read textures from external sources. Somewhat unsurprisingly, the 26-year-old map format is probably not the best option for us. Before moving on to other formats, I'd like to mention that nowadays mappers don't use the actual 1996 version of the format. The format was expanded several times over the years, and currently Fbsp 2 is the popular choice. It does not provide any significant benefits for DreamRealms, but it eases the process of map creation while keeping up with the original spirit. If you've played a recent map or a mod, you most likely encounter Fbsp 2. The biggest thing to mention about Quake 2 is that the textures are now loaded from an external source, by default, and the format provides colored lighting. That's not too big of a step up since Fbsp 2 already provides an option for colored lighting, so we're moving on. Quake 3, naturally another step up. Finally, the palletization has been ditched, and True Color rules supreme. The most interesting thing to mention is actually patches. No, not the kind you download from the internet to make the game run correctly. These patches are a tool to use when mapping. They can be used to create Bezier curves and give our maps some additional polish. It is not a necessity, however, and with modern tools, curves can be made through other means. Quake 3 Fbsp, however, no longer stores lightstyles. Oh, what's a lightstyle? Lightstyles are an effect used in Quake, and games derived from it, to make lighting more interesting. These are defined by the developer in a string of text that looks something like this. A represents 0 brightness, while M is 100% brightness and Z is 200% brightness. This is not the case across the engines, however, so you might want to check that out for your own specific case, but this is just a rule of thumb. You've probably seen these flickers more often than you'd think, especially this flicker. That's the Quake lightstyle for fluorescent flicker and has been reused numerous times in various games, most notably Valve games, all the way up to Half-Life Alyx. Moving on, we arrive to the Valve family. Valve took the magic of id Software and applied some of its own pixie dust, creating some of the most influential games. Half-Life 1, or the Gold Source format, is a result of a few changes done in order to fulfill the vision Valve had. For one, the game no longer has one palette for all textures, but each texture has its own palette. Textures are still stored in the Fbsp file like Quake 1, but they do support external textures, mainly through WAD files. Half-Life ships with the WAD files since the game can load textures from them during runtime. While impressive that the ability is there at all, loading Half-Life 2 or source maps in Forethought is still limited, so it's currently off the table. Certainly it would be nice to use Displacement, which are brushes that are turned into a more classical style of a 3D model. They're used for terrain and details, but they're not necessary, because similar effects can be achieved through different means. The offshoots are not inherently a style of a format, but they have done some improvements over the years, so they're worth mentioning. The Raven Fbsp. This is a simple one. Apply everything I said about Quake 3, but there's one difference. Raven Software brought back lightstyles. Fbsp is another simple one, because it's essentially the Raven Fbsp with high-resolution light maps to make him look nicer, and some minor performance optimizations. If you've played Warsaw, you've seen this one. So now that I've laid out all the options, what have I chosen for DreamRealms? Fbsp, naturally. Except I'm lying to you. Currently all but one map are in the vanilla Quake 3 format. There wasn't a need for anything else so far, but I would like to target Fbsp because of the benefits it provides. I hate to split up video like this, but I wanted to get something out this month. Next time we'll take a look at the map compilers, but until then here's some other stuff you might be interested in.